Okay, welcome back. 11.2. Now we get another way of solving these quadratic equations, and it is the quadratic formula. Okay, so let's take a look. If you're given an equation ax squared plus bx plus c equals 0, then the solutions can be found by just plugging them into this formula. Okay, so x will be negative b plus or minus square root of b squared minus 4 times a times c all over 2a. Okay, so you got to have this memorized, all right? Let's take a look. So number 3, we have x squared plus 8x plus 12 is 0. We have two ways of solving this as of right now. We could just, the easiest way, and the way you always want to try first, is to just factor the thing. Okay, so this would be x plus, you want two numbers, multiply the 12, but add the 8, so 6 and 2. Okay, and then set each part equal to 0 and solve. So x plus 6 is 0, x is negative 6, x plus 2 is 0, so x is negative 2. Okay. The other way we learned last time was completing the square. And now we have another way, is just using the quadratic formula. So using the quadratic formula, first thing I like to do is identify my a, b, and c values. A is the thing in front of x squared, that's just 1. And b is the thing in front of x, it's 8. And c is the last thing you see is 12, the constant. Okay, then I'll plot that stuff into my formula. I like to do some parts in my head and some parts I sort of leave for my next step. So x equals negative b, so negative b is negative 8, plus or minus the square root of b squared, so 8 squared is 64. I can do that in my head, so I'm not going to write out, 8 squared, and then I sort of just leave everything else for the next step. So minus 4 times a times c, and then all over 2 times a. Okay. Okay, from there on out, it's just a matter of simplifying. So negative 8 plus or minus square root of 64 minus 48, and that'll be all over 2. Right, so that'll be negative 8 plus or minus square root of, we have 48, 64, 16, all over 2. And then what do we get? Negative 8 plus or minus 4 all over 2. So x is negative 8 plus 4 over 2, which is negative 8 plus 4 is negative 4 all over 2, which is negative 2. Or x is negative 8 minus 4 all over 2. Negative 8 minus 4 is negative 12. Over 2 is negative 6. So negative 2 or negative 6, and of course that's what we got up here, negative 2. So you get, it's just another way of solving these equations, and it's useful when you can't necessarily see any factorization. But it is a high-powered sort of tool, and you don't want to pull it out just any chance you get, because it's more work to do all of this stuff than it is to do this stuff. Okay? And if you do more work, there's more probability for error, and we want to avoid error. Okay, so let's look at another one, number 5. So we have x squared plus 3x minus 20 is 0. And again, like I said, your first instinct, hopefully, and we don't want you to use the quadratic all the time, right? So their first instinct, hopefully, is to try to factor it, and you say, okay, it's x and x, and then it has the signs have to be plus minus, and then you're thinking factors of 20 that add to 3, and there really aren't any, right? So 4 and 5, 2 and 10, 1 and 20, there just isn't any. Right? So you're forced to use some other method in this case, and that method is the quadratic. So A is 1, B is 3, C is negative 20. I'll go ahead and put those into my formula. X is equal to negative B, so negative 3 plus or minus square root of B squared. 3 squared is 9. Minus 4 times A times C, all over 2 times A. So then I got negative 3 plus or minus square root of 9. Negative times negative is plus, looks like 80, all over 2. And then we just keep simplifying. This is negative 3 plus or minus square root of 80 plus 9 is 89, all over 2. And I don't think 89 will factor at all, not into a perfect square at least. And so we'll have to leave our answer in this form. This is a fine way to leave your answer. It depends on what you want to do with it, right? So if we were graphing basically the zeros of this as a function, so in the next section we'll want to graph these things and call them parabolas there. If you wanted to graph this thing, you would need to know where it hits the x-axis, okay, the x-intercept, basically. So in those cases, you may need to take this thing and get decimal approximations for the two solutions. Okay? So it just depends on what you want to do with it, but for our purposes, that answer is fine. Let's look at number 9. We have 6x squared equals 2x plus 1. And the first thing you need to do is get it into this, set it equal to 0. We want to get it into a form where we can use the quadratic. Otherwise, yeah, I mean, you literally cannot put 6, 2, and 1 into the quadratic and expect it to work here. It won't. You have to go 6x squared minus 2x minus 1. I think that's been a common theme for us throughout the semester. You have to get stuff into the form where we already have the tools set up to just kind of plug and chug it. Anyways, here are the A value is 6, the B value is negative 2, the C value is negative 1. I'll plop it into my quadratic. So x is equal to negative b. Negative negative 2 is 2, plus or minus the square root of negative 2 squared is 4, minus 4 times a times c. And then that's all over 2 times a. And then we'll simplify. So I have 2 plus or minus square root of 4 plus 24 all over 12. That'll be 2 plus or minus square root of 28 all over 12. I want to simplify this thing. I think there's a perfect square in there, right? So it's 2 plus or minus square root of 4 times 7 all over 12. You can march the 4 out the front. 2 plus or minus 2 radical 7 all over 12. And then when you simplify this guy, you need to factor the numerator and denominator to do that. So factoring the numerator, I can bring a 2 out of both terms, 1 plus or minus radical 7. The denominator is 2 times 3 times 4. Okay, so I can remove the 2's. 2 over 2 is 1. And then you're left with 12 in the denominator. So our final answer, 1 plus or minus radical 7 all over 12. Oh, sorry, all over, geez, that was 2 times 3 times 2, sorry. So it's 1 plus or minus radical 7 all over 6. Sorry. Okay, all right. Let's see if I get another chance of redemption here. Yes, I do. 15. Okay. Okay, so we'll have 3x squared equals 8x minus 7. And the first step is to get it into, or set it equal to 0 rather. 3x squared minus 8x plus 7 is 0. And I can't really factor it off the top of my head, so I'm going to go to the quadratic. A is 3, B is -8, and C is 7. So plop it into my formula. X is -b, so -8 is 8, plus or minus the square root of. B squared is 64, minus 4 times A times C. And then that's all over 2 times A. And start simplifying. 8 plus or minus square root of 64 minus 84. And some of you may be freaking out. Uh-oh, there's going to be a negative in the radical, right? The stuff in the radical is called the discriminant. We're going to talk about that in more detail in the next section. Okay? But yes, the discriminant here is negative, so we're going to have imaginary solutions. So here it'll be x plus or minus square root of -20 all over 6. We can march out the perfect square out the front door. I'm going to take the imaginary guy out back. So it's going to be square root of 4 times 5 times square root -1, which is I, over 6. I'm going to factor, square root of 4 is 2, so 8 plus or minus 2 square root 5i over 6. And then finally, we could factor the numerator and denominator. I could factor a 2 out of this expression, so I'll have 2 times 4 plus or minus root 5i. 6 is 2 times 3, so you can remove the 2's, and you get 4 plus or minus radical 5i all over 3. Okay. If you remember our work with imaginary numbers, there's sort of a standard form we want it in. We want it in the form a plus bi. So you want to keep the real and the imaginary part separate. So with that in mind, we fillet or butterfly this fraction. You'll end up with 4/3 plus or minus radical 5 over 3i. Okay? So your a value is the 4/3. Your b value is radical 5 over 3, or negative radical 5 over 3. Okay, so anyways, you could tell that you're going to end up with this type of solution just by looking at the discriminant. And that's what we want to look at next. The discriminant will tell you your solution types. The discriminant. I believe there's an I right here. I'm sorry, I'm not a very good speller. So given ax squared plus bx plus c, the discriminant of this character, there I go again, is the junk underneath the square root. Okay, so it's the b squared minus 4ac. So, like I said, you could tell the kind of solutions you're going to get by looking at this. And basically, if this thing is greater than 0, you'll have 2 real solutions. If this thing is equal to 0, you'll just have 1 real solution. And then if the thing is less than 0, like it was in the previous case, you'll have no real solutions, but then you'll have two complex solutions, or 2 imaginary. Okay, so there'll be questions. They'll give you questions, and all you're doing is sitting there figuring out the types and the number of solutions. Let's take a look at, 30. So we have 4x squared equals 20x minus 25. Right? So as usual, I'll set it equal to 0. 4x squared minus 20x plus 25. And then I'm going to, set it equals 0. I'm going to go ahead and look at the discriminant. So the discriminant is b squared minus 4ac. So b squared is negative 20 squared minus 4 times a times c. So I'll have 400, 20 squared is 400, minus 16 times 25, that's going to be 400 as well. So here I should have one real solution. And it's important to kind of think about it. What is, going to be our, if we went through the motion, so to speak, x is negative b, so 20 plus or minus the square root of negative 20 squared, which is 400, minus 4ac, all over 2a. Right? And then this will be 20 plus or minus. So the reason why we only have one solution in these cases is because this stuff will all be 0, right? So from above, we saw that was 400 minus 400 all over 8. So it's basically going to be 20 plus or minus 0. Right? So 20 plus or minus 0 is just going to be 20 all over 8. And you just have this one solution. Okay? So 5 over 2. Okay. Now we want kind of want to do some back engineering. So what they're going to do is give you the solutions, and you want to create the original equation. Don't ask me why. It's something they are experimenting with. Writing. I don't know why I think that's funny. Writing quadratic equations from solutions. Okay, so it's kind of a reversal process, and let's see if we can. Well, maybe we need a refresher here. Let's look at this guy. X squared minus 4x minus 12 is 0. How would I solve that? Well, hopefully you could factor it, right? And certainly we can factor this one. X and x plus and minus has to be 6 and 2. Bigger number is negative. So our solution is x equals negative 2, x equals 6, or how the software likes to write it, it'll be the set of negative 2 and 6. Okay. Now we want to start here and go backwards. Okay. So in problem 52 in the book, what they do is just give you the answer. So negative 2 comma 6. And then you have to work back. So it's going to be x equals negative 2 or x equals 6. And then you could add 2 to both sides. So x plus 2 is 0 or x minus 6 is 0. And then you can multiply these together. X plus 2 times x minus 6 is 0. And then FOIL it and you have the original. Plus 2x minus 6x is minus 4x, and then minus 12 is, and that's what they want. Okay. Okay, so let's look at another one. I guess this can be, more useful than I'm maybe suggesting it is when you're trying to create equations to model data. So in statistics, a lot of times you'll have data points occurring, and then you want to make predictions based off the data points. So if you can kind of figure out maybe or back engineer something that goes through those points, you can make predictions about other kinds of data. So in the long run, maybe we'll have a data point here or something like that. I don't know. Okay, so statistics, that's going to be my sort of reasoning. Anyways, let's look at this guy. So x is that, or x is this, and then we just back engineer. Okay, so reversing everything, x plus radical 3 is 0, or x minus radical 3 is 0. Then we multiply these together, it will be x plus radical 3 times x minus radical 3 is 0. And then we can FOIL it out, right? So we have x squared, first the outer minus radical 3x, the inner plus radical 3x, and then the last is minus radical 9, which is 3. The two middle terms will add away, and we're just having x squared minus 3 is 0. And that's it. Let's look at one where they have some imaginary characters floating about. So number 62. We have 2 plus I, and then 2 minus I. Curly bracket there. So I'm going to have x equals 2 plus I, or x equals 2 minus I. Watch the way I do this. I don't necessarily, well, you judge for yourself. Okay, so I'm going to move this entire thing to the other side. Rather than minus 2 minus I, I'm just going to write minus 2 plus I. Right? And then here, instead of minus 2 plus I, I'm going to write x minus 2 minus I. And so I just subtract 2 minus I from both sides. Now I'm going to have my equation, x minus 2 plus I times x minus 2 minus I is 0. FOIL x squared first, the outer minus x times 2 minus I, the inner minus x times 2 plus I, and then the last negative negative is positive, and we're going 2 plus I times 2 minus I. Okay, okay, so that'll be x squared minus, distributing the x, 2x plus xi, and then here distributing the x minus 2x minus xi, and then finally FOILing this guy, so I'll have 4 minus 2i plus 2i, and then minus I squared. And so the weird thing is you have these imaginary solutions, but the actual original formula doesn't have any of that imaginary stuff, right? So we have x squared minus 4x, 2x minus 2x, xi minus xi is 0, and then we have a plus 4, and then minus 2i plus 2i is 0, and then minus I squared, and I squared is negative 1. Right? And then I think we can, well, let's just go right here, x squared minus 4x plus 4, negative negative 1 is plus 1, so plus 5 is 0, and that would be our final answer. Okay, I want to look at one application. So this is 77 in the book. They give us a nice formula. F of x equals 0.013 x squared minus 1.19x plus 28.24, where f of x is equal to the fatal crashes per 100 million miles. Very grim example here. Fatal vehicle crashes per 100 million miles. About something an actuarial maybe would be interested in. Somebody who works at an insurance agency. They do a lot of numbers and stuff like that. If you want a job in insurance, that's a great job to get. Insurance or banks. places like that, you work with numbers. Okay. First off, what groups are expected, what age groups basically are expected to be involved in 3 crashes per 100 million miles? Okay, so the deal is I want x from this equation where the output is 3. Okay, so what you do is put 3 in for f of x and then solve for x. Okay, so 3 equals 0.013x squared minus 1.19x plus 28.24. Then subtract 3 from both sides, so essentially setting it equal to 0. And then you could put it into your quadratic formula and get some numbers. Okay, so I'll probably be using my calculator here rather than doing this in my head, but let's set it up. Okay, so negative b is 1.19 plus or minus the square root of b squared. So negative 1.19 squared minus 4 times a, which is 0.013, times c, which is 25.24, all over 2 times a. Okay, you'll want to use your calculator and get some practice putting this into your calculator. It's a big, ugly thing. It's easy to make some mistakes, so you need to practice it. Okay. After you do, you'll get approximately 58 for one answer, the plus version, and then when you do the minus version, you'll get 33. So it's expected that 58-year-olds or 33-year-olds will be involved in 3 fatal crashes per 100 million miles. Okay. So 3 fatal crashes per 100 million miles. Okay, so that will do it for the quadratic formula. And next time we'll be working with graphing. So see you next time.